Now we'll be looking at row echelon form. We will look at conditions of a matrix to say that it is in a row echelon form or not. Please like, share and subscribe this particular channel. Let us start now. Coming to row echelon form. It is used to solve any linear equations. Okay. Now for this one, we have a few conditions to say that it is in a row echelon form. Coming to the first condition, it's nothing but all the leading entries in each of the row of the matrix are 1 and they are known as nothing but leading 1. We'll be going with an example. Okay, it's nothing but if you consider this particular matrix. In this particular matrix, the leading one, okay, this is nothing but in a row, right? In this particular row, the leading one, the first one should be 1. Again, is similar in the row. Second row also, the leading one should be 1. Coming to third one also, leading one is also 1. And if it is 0, it's fine. Okay, but 1 should be in a leading 1, and it is known as a leading 1. These ones are nothing but leading ones in this particular matrix, right? These are the first condition. Come to the next one. If a column contains a leading 1, then all the entries below the leading 1 are zeros. Means nothing but this is nothing but a column. This is a row, this is a column, and in the leading one below of it should be zeros. Okay, and if you consider this particular column, this is a leading one, so below of it is nothing but 0, and this is nothing but 1, below of it should be 0. Okay, second condition also not satisfied. Come to the third one. Each of the leading one is to the right of the any of the leading one above it. Okay, it's saying that if you consider a leading one here, this one, then it should be the right of the above leading one. Yes or no? It is at the right. It is forming in a sequence. That's it. This is in a third condition. Coming to the fourth one. It's nothing but any row which contains all zeros is below the rows which contains a non-zero entries. If you consider this particular rows, this is in a row 1, this is a row 2, and this is nothing but row 3. And row 4s have all zeros, right? All of them are 0. It should be below all the rows which are having a non-zero entries. You can see that these 3 of them we have a non-zero entries, right? So 0 entry should be below the non-zero entry. Okay, these are the conditions of a row echelon form. Now coming to few more examples of a row echelon form. What are conditions? There are 4 conditions, right? The first one is nothing but the starting entry should be a leading entry of a row should be 1, and second one is nothing but a row has a leading entry, then below of it should be 0, and third one is nothing but a leading entry should be at the right of the other leading entry above it, and coming to the fourth one is nothing but all the zeros should be at the bottom of a non-zero row, right? Coming to the first one, you can see that the starting one is nothing but a leading entry. Here also this row also leading entry. This is also leading entry. So first condition got satisfied. Come to second one. In a column, leading entry below should be zeros. So it is 0, it is 0. So second condition also got satisfied. Third one. Third one is nothing but the leading entry should be at the right of the other leading entry, right? So this is nothing but right of it. And this leading one is at the right of the other leading one, right? So third one got satisfied, and fourth one is nothing but all the zeros should be at the bottom of a non-zero entries. It does not have it, so it is nothing but row echelon form only, this matrix. Come to the next one. Consider this particular matrix. Okay, we have 4 conditions: 1, 2, 3, 4. Come to the first condition. Starting entry is nothing but 1, right? It's a leading one, right? First one got satisfied. Second one, the column of a leading one below of it should be 0, but this is not 0, right? It does not satisfy, right? So this is nothing but not in a row echelon form. Coming to the next one. If you consider this one, the first condition is nothing but the leading entry should be in a 1 of an row, right? It's satisfied. This also got satisfied, right? It's fine. Come to second one. The column leading one below of it should be 0. So it is 0, it is 0. And here also it is 0. It got satisfied. Come to third one. The leading entry above it should be at the right of it, right? So it got satisfied. Fourth one. All the 0 should be at the bottom of a non-zero rows. So it is nothing but satisfied. So there is nothing but a row echelon form. Coming to this one. The first condition is nothing but all the leading entries should be nothing but 1 in a row, right? So it got satisfied. Come to second one, right? Second one is nothing but below of the leading one should be 0. It is 0 here. It is not 0. It does not satisfy, right? Let us check the third one also. What is third one? Is nothing but the leading one should be at the right of the other one, which is an above it, right? It is at the right. But this one is not at the right. It is at the left, right? Third one also does not get satisfied. So it's nothing but not in a row echelon form. Okay. Now basic note point that we know is nothing but row echelon form is used to solve in a linear equations. So let us solve one of the equation on it. You consider this particular 3 equations. Okay. When we are writing this one in the form of a matrix, then we get nothing but 1, 1, minus 1, minus 2. This is nothing but 2, minus 1, 1, and this is 5. And this is minus 1, 2, 2, 1. This is nothing but a row echelon form. You have to convert it. So what operation do we do is nothing but R3, row 3, when you add it with row 1. Okay, such that it becomes 0. And the other one is row 2 is equal to row 2 minus 2 times of row 1. Such that the row here, the row is nothing but leading one is 1 here. And column in the column below of it should be 0. So when you're going with the second step, such that the column leading one below of it would be 0. So the matrix would be changed to 1, 1, minus 1, minus 2, and this becomes 0. This becomes minus 3. This is 3. This is 9. And this is 0. Right. So this one becomes 3. And this is nothing but 1. This is minus 1. Right. This is a matrix. We got it. Now what we do is nothing but when making this particular value as a 0. So what we do is nothing but R3 is equal to R3 plus R2. Right. Then we get in a matrix. That is what 1, 1, minus 1, minus 2. And this is 0, minus 3, 3 and 9. And this is 0, 0. Now this one is nothing but 4. This is 8. Right. Now here one leading one is there. Below of it is 0. And next to one leading one should be become 1. And below of it should be 1. So what we do is nothing but root 2 is equal to nothing but root 2 by minus 3. Okay. And row 3 is equal to row 3 by 4. If you do this one, it becomes nothing but 1, 1, minus 1, minus 2. And 0, 1, minus 1, minus 3. And here it is 0, 0, 1, and 2. You got this particular equation. If we write this one in the form of linear equations, then it get x plus y minus z is equal to minus 2, and y minus z is equal to minus 3, and z is equal to 2. You got a z value is equal to, then what is the value of an a? Y. It becomes minus 1. We got an a z and y value, then we get an a x value, right? Y is nothing but minus 1, z is 2, minus 2, right? So we get an a x value is equal to nothing but 1. This is the method, right, to solve an linear equations. Now second point that we know is nothing but any matrix can be put in an equivalent row echelon form by using a elementary operation. It's nothing but, if you see here, you have done nothing but an elementary operation, right? And we have done it into row echelon form. So any linear equation can be converted into row echelon form by doing an elementary operation, right? Come to the third one. By row echelon form, we can find the rank of the matrix. Yes or no? If you consider this particular matrix, it's nothing but 3:4 matrix. So rank of this one matrix is equal to nothing but 3. So it is easy to find the rank of the matrix, and it is easy to solve any linear equations.